Walk into your attic on an afternoon in July, and the heat hits you like an open oven door. 140 degrees, sometimes 150. That superheated air is sitting 6 feet above your head right now, pressing down on your ceiling, radiating into every room below, forcing your air conditioner to fight a battle it was never designed to win. And every month you are paying for that fight. Here is what almost nobody talks about. There is a $4 device, simple enough to install in a single afternoon, that vents that trapped heat out of your attic and keeps your living space measurably cooler without your air conditioner running nearly as long. It requires no electricity from the grid, no permit, and no contractor. It existed long before central air conditioning was ever sold to the American public. So if it works this well, why has almost everyone stopped using it? Most people think of their attic as empty space, a place to store old boxes and forgotten furniture. But during a typical American summer, that space transforms into something far more consequential. Solar radiation hammers the roof surface for 8 to 10 hours a day, and the attic below it functions less like a room and more like a thermal battery, absorbing and storing heat with nowhere to send it. Temperatures inside that space routinely climb past 140 degrees Fahrenheit. On the hottest days of summer, 150 is not unusual. And that heat does not simply sit there waiting to dissipate. It radiates downward through your ceiling and into the living space below, raising the temperature of every room in your home, even when your air conditioner is running at full capacity. The problem compounds further when you consider where most residential ductwork is located. In the majority of American homes built before the year 2000, the ducts carrying cooled air from your system run directly through that superheated attic space, which means the air your system just spent energy cooling is warming back up before it ever reaches the rooms it was designed to serve. Your air conditioner is essentially fighting itself. The numbers behind this are sobering. According to the United States Department of Energy, every degree of attic temperature increase can push your cooling load up by as much as 4%. In a home with an attic running 30 or 40 degrees hotter than it needs to be, that translates directly into hundreds of additional dollars on your summer utility bills, year after year. Put simply, your electric bill in summer is not cooling your home. It is cooling your attic first, and whatever capacity remains trickles down to you. That is the real cost of an unventilated roof space. And it is a cost that has been built into the design of American housing for the better part of 70 years. The solution, it turns out, has nothing to do with a more powerful air conditioner. The idea that a house should breathe is not a modern innovation. The original American farmhouses of the 1800s were built with attic ventilation as a standard feature, not an afterthought. Gable vents at each end of the roof, ridge openings at the peak, soffit gaps along the eaves. Builders of that era understood something that has been largely forgotten. A roof is not just a lid. It is a thermal management system. And when it is designed correctly, it releases heat the same way a chimney releases smoke. That understanding produced real engineering solutions. In 1910, a man named Samuel Ewart patented a spinning roof ventilator that actively pulled hot air out of a building, using nothing but the kinetic energy of the wind. No fuel, no electricity, no moving parts beyond the rotor itself. It was a device built entirely around the physics of how air naturally behaves, and it worked. By 1938, the science behind passive attic ventilation was well documented. A researcher named Everett Schumann, working at the Pennsylvania State College Building Research Laboratory, published a study that confirmed what builders had known for generations. Houses with proper cross-ventilation in the attic space stayed measurably cooler in summer and consumed dramatically less energy overall. His study recommended a minimum of 1 square foot of net-free ventilation area for every 150 square feet of attic floor space. That ratio became the national standard, and builders followed it for decades. Then something shifted. Around 1955, as central air conditioning moved from a luxury item into a standard feature of new residential construction, the economic incentives changed. A sealed house sold more equipment. A breathing house sold less. Ventilation requirements were quietly relaxed. Insulation was marketed as the complete solution. And the idea that a roof could manage heat on its own, without electricity and without monthly bills, was gradually pushed to the margins of mainstream building practice. The physics, however, did not change. Only the business model did. The principle at the center of this system is called the stack effect, and it requires no technology to understand. Hot air is less dense than cool air. It rises. If you give it a path to exit at the top of your house and a path for cooler air to enter at the bottom, the attic stops being a heat trap and starts behaving like a chimney. Heat exits continuously, pulled by physics rather than electricity. The cooler air flowing in from below keeps the attic temperature close to the outdoor ambient. Your ceiling stays cooler. Your air conditioner runs less. Your bill drops. The device that makes this system work intelligently costs $4. It is a thermostatic switch, the kind sold at any hardware store, wired in line between a small 12-volt DC fan and a modestly sized solar panel mounted to the exterior of the gable. The fan itself sits inside the gable vent you almost certainly already have. The panel mounts on the south-facing side of the gable, where it receives maximum sun exposure throughout the day. Here is what makes this particular combination so effective. When the sun is strongest, the panel produces the most energy, the fan spins at its highest speed, and the attic is being actively ventilated at exactly the moment it needs it most. When the sun goes down and outdoor temperatures drop, the panel stops producing power, the fan stops, and the attic has already shed the heat it accumulated during the day. The system is self-regulating by design. The thermostatic switch adds one additional layer of intelligence. Set it to activate at 95 degrees Fahrenheit, and the fan only runs when the attic actually needs ventilation. Not on cool mornings, not on mild days, only when the thermal load justifies it. Total parts cost for this system runs under $50, including a salvaged 12-volt fan, a 20-watt solar panel, and the $4 switch. A properly ventilated attic can stay within 10 to 15 degrees of the outdoor ambient temperature, compared to 150 degrees in an unventilated space. Every dollar saved on cooling from that point forward is a pure gain. Ventilation handles the air. But there is a second heat transfer pathway that most homeowners never think about. And it is responsible for a significant portion of the heat that ends up in your bedroom at 3 in the morning, even after the outdoor temperature has dropped. Heat does not only travel through the air in your attic, it conducts directly through solid material. Every rafter, every joist, every wooden structural member running between your roof deck and your ceiling acts as a thermal bridge, carrying heat downward by conduction the same way a metal spoon left in a hot pot transfers heat directly to your hand. Your insulation may be rated at R30 in the cavities between the joists, but the wood of the joists themselves has no such rating. It conducts heat continuously, all day long, regardless of how much insulation surrounds it. This is called thermal bridging, and it represents a structural flaw built into virtually every conventionally framed American home. The solution is not more insulation packed into the same cavities. The solution is to interrupt the conductive path before it reaches the insulation layer entirely. A reflective, radiant barrier laid across the top of the rafters, not between them but across them, creates exactly that interruption. Heat traveling down through the wood encounters a reflective surface and is redirected back upward, before it can continue its path into the living space below. The Oak Ridge National Laboratory confirmed in a 1986 study that a properly installed radiant barrier reduces residential cooling loads by up to 17% on its own, independent of any ventilation improvement. The material costs approximately 30 cents per square foot, purchased in rolls from any farm supply or building materials store. A typical attic requires around 600 square feet of coverage, bringing the total material cost to roughly $180. Combined with the solar ventilation system, the two work as a unified thermal management strategy. Independent testing supports a 30 to 40% reduction in summer cooling costs when both components are properly installed. The total investment for the complete system lands well under $250. So why has none of this been standard practice for the past 50 years? The answer is not complicated, but it is worth understanding clearly because it explains why a system this effective and this affordable has been systematically absent from mainstream housing construction for decades. By the early 1970s, as central air conditioning became a default feature of new residential construction, the economic incentives of the building industry shifted in a specific direction. Insulation manufacturers, whose revenues depended on selling the idea that sealing a home tighter was always the correct answer, pushed aggressively for construction standards that favored their products. The fiberglass insulation industry alone represented billions of dollars in annual revenue. Every dollar of that revenue depended on convincing builders, code writers, and ultimately homeowners that more insulation packed more densely was the only legitimate response to high energy bills. Ventilation, which costs almost nothing and generates no recurring income for anyone, became an afterthought. The regulatory environment followed the money. By 1991, radiant barrier technology that had been developed by NASA for use on the Apollo spacecraft and subsequently validated by independent laboratory research was quietly removed from most residential building guides. The International Energy Conservation Code and similar regulatory frameworks began mandating mechanical ventilation systems with guaranteed air exchange rates, a standard that passive systems dependent on wind and temperature cannot meet by definition, regardless of their real-world performance. Homeowners associations compounded the problem further by restricting visible roof ventilation hardware on aesthetic grounds, prioritizing the appearance of clean, uniform roof lines over the thermal performance of the homes beneath them. The result is a housing stock in which generations of American homeowners have been paying monthly utility bills for a problem that building science understood how to solve passively and cheaply before 1940. Not because the solution stopped working, not because the physics changed, but because passive systems do not generate equipment sales, installation contracts, or recurring service revenue. The technology was never lost. It was simply never in anyone's financial interest to keep it visible. Clear your soffit vents. Install a solar-powered gable fan with a $4 thermostatic switch. Lay a reflective radiant barrier across your rafters. 3 components. Total investment under $250. No contractor required. No permit to file. No monthly bill attached. The system pays for itself within a single cooling season and continues delivering savings for decades afterward without maintenance, without replacement parts, and without any ongoing cost of any kind. The heat wants to leave. Your job is simply to let it. If you want to understand how these same principles of thermal movement can heat an entire home through winter without a furnace, watch the next video here.